Welcome. Look at the SPY daily chart on screen. That tracks this S&P 500. That up and down price path is mathematically close to how light moves. Today's lesson is why physicists flooded Wall Street, and the story sitting right in the middle. Nature's laws and market moves share the same skeleton. You'll learn three things. First, the random walk. Price as a random step. Second, where path integrals, adding every path light can take, meet the efficient market hypothesis. Third, Black-Scholes delta hedging, and the market paradox that the moment you find a pattern, that pattern starts to vanish. One caveat up front. Today gives you a probability lens on markets. It does not promise that any formula will make you money. Keep that in mind, and let's begin. This screen is Bitcoin on the daily. It climbs forever, then snaps hard, again and again. The mathematician who first caught that seemingly random motion in math lived in 1900. French mathematician Louis Bachelier, in his doctoral thesis, treats stock prices as a random walk. The next step's direction can't be predicted. His goal is a fair price for options. Amazingly, only 5 years later Einstein explains Brownian motion, pollen jittering on water, and lands on almost the same math. Einstein explains that motion as random molecular collisions, and his diffusion equation has the same structure as Bachelier's heat equation. Different purpose, different subject, same math. That markets and nature look this alike is where today's lesson starts. Now shift to the SPY weekly, still the S&P 500 lens. Noise drops versus the daily, but it still won't tell you next week's direction with certainty. Enter the efficient market hypothesis. All available information is already in the price, so the direction of future price changes is unpredictable. A Galton board shows the paradox cleanly. Drop a ball onto a board studded with pins like thumbtack tips, and you can't know whether that one ball goes left or right. It's 50-50. But drop thousands of balls, and the pile below always settles into the smooth bell of a normal distribution. Individuals unpredictable, the crowd patterned, both true at once. So, not knowing the next candle's direction does not mean the market has no structure. Like the outline SPY weekly draws over long stretches, the shape of the distribution is real. Now look at Apple on the daily, a NASDAQ heavyweight. It's easy to think the next price has one fixed road. Physics offers a weirder picture. That's Feynman's path integral. When light goes from A to B, it doesn't follow one path. It explores every possible path at once. In the double slit experiment, as you keep adding slits, in the extreme limit, an empty space with infinitely many slits becomes mathematically the same as the sum of all paths. Each path carries a phase. Think of a tiny stopwatch glued to it, and the result is set by adding all those stopwatch hands together. By analogy, you can treat the next stock move as a probability field of countless paths laid down at once. But this is only a teaching metaphor. It is not a claim that quantum mechanics applies to markets as is. Back to the SPY daily. In Feynman's picture, the real magic starts after you add every path. When you sum the phases, paths with mismatched phases cancel each other through destructive interference. Almost all of them vanish. What survives sits near the path of least action. The single straight trajectory we trust for light is really just those surviving paths stacked together. Something similar happens in markets. A statistical pattern someone finds becomes an arbitrage target. The trading itself gets priced in, and the pattern slowly cancels out. Even a stretch that looks like a repeating pattern today often fails to repeat a few months later. That's why overconfidence in patterns always needs a guardrail. Whether you're watching the S&P 500, NASDAQ names, or anything the Fed cycle moves. Look at Apple on the weekly. Over long stretches, it trends higher, but deep drawdowns sit in the middle. One way to handle risk on that kind of path starts with the Black-Scholes-Merton option pricing formula of 1973. The core idea is delta hedging. Blend an option and its underlying so that whichever way price moves, the risks cancel, a near risk-free portfolio. By analogy, no matter how price paths wander, you're trying to keep the portfolio's trajectory as flat and stable as possible, closest to a least action path. After that formula, derivatives markets expand widely and become a pillar of modern finance. But one point needs to be clear. Hedging does not erase risk. It hands risk to someone else and redistributes it across the market. Lose that balance, and the hedge itself becomes a new risk. Like thinking a barla 3 coffee stays barla 3 forever when inflation and Fed policy are already rewriting the menu. Finally, open the SPY monthly. On a long time axis, markets look like they hold consistent patterns. So here's one famous historical case. Jim Simons's Renaissance Technologies Medallion Fund is widely reported to have substantially beaten the market average for roughly 30 years from 1988. Exact figures differ by source, and nothing guarantees you can reproduce them. We borrow only that historical fact. It never means you can easily earn the same. Discover a statistical pattern in the market and trade it, and that trading itself gets reflected in price. The pattern disappears. The paradox: the moment you find the pattern, you erase it. So markets converge back toward efficiency, Feynman's destructive interference playing out again. Drop overconfidence in any single formula. See the market as a probability distribution and manage risk. That attitude is the real edge. That's it for today's lesson.